What we are going to actually go through today, instead of our regularly scheduled program, is just like, I'd say like just troubleshooting stuff, right? So, how many of you like some troubleshooting pro tips for going through playing with Firewall? Eh? Yeah. So that's kind of the name of the game. So, unlike, kind of like when you write a program in C, if you miss a semicolon on the second line, you're like the whole rest of the program is just going to explode on you, right? So firewalls are really not that much different in networking. Like, you have to get it all right. Otherwise, maybe none of it's going to work. So it can be kind of frustrating to try to pick apart the pieces and see like what layers of stuff do we have working. Oh, get it layers because it's like OSI model networking. Yeah, see, telling jokes this morning already. OSI model jokes. So that's how today's gonna go. So gear up for that. So the first parts and honestly kind of most common mistakes that I've really ran into are just mismatched IP addresses. This has actually happened quite a bit. So double check, like double, quadruple, triple check. I know you may not be able to copy and paste IP addresses out of the PDF into the machine, but really super check on that, because a lot of the times, and even when I pop into the machines to help out, I think there's like 4 or 5 different folks. I probably spent sitting in my hotel room like 15 or 20 minutes going through and like, what in the world? Why doesn't any of this work? Because I started all the way at the top and like reverse engineering firewall rules, only to find out like, oh, they configured their DMZ interface to be 42 instead of 43. And then the server that's already configured with an IP address couldn't talk. So that's a big one. With that being said, when we look at all of the machines that are on the DMZ interface, what is their default gateway going to be? Or their default route? What interface are they going to talk to? Or what IP address are they going to talk to? Machine on the DMZ network. I'll pull up the list again. Are they going to talk to this IP address, where my cursor is? The 64.43.242.1. Will a DMZ machine ever talk to that? Why not? Why isn't it going to talk to that? Do you not know? Or are we just playing? Not necessarily a rule. When a computer on the DMZ wants to leave its subnet, who does it need to talk to? The router. What interface of this device does it need to talk to route out on? On the DMZ interface, which one's it going to be? Are you for real? You got 3 choices right there. So if a computer is on this interface, DMZ interface, and it wants to leave its network, it's sitting here plugged in here to this network, DMZ, MSP DMZ, and let's take this server right here. It wants to leave. It has a packet going somewhere else. Where is it going to go on our firewall first? Will it? If a machine on this interface wants to leave, who is it going to talk to first? If I want to leave East Hall, room 105, and go outside, is the first doorway I encounter going to be the outside glass doors? Yeah, it'll be the DMZ. Just like if I want to leave this room and go somewhere else, I have to go through that door first, right? Make sense, right? It's It's going to be a while before I get to the glass doors on the outside of the building. So I have to go through this door first. If I am on this DMZ interface, if I'm connected right here, if I want to leave, I have to go through that interface first. Make sense? I'm getting worried. Getting worried. So, the first thing we should do if you're having troubles getting a device to leave the network is check its connectivity. So this could be many reasons why. Like maybe your interface in pfSense is disabled. Maybe the IP address is set incorrectly. So when we come in here, starting at the physical layer, do you guys have any control over the physical layer with VMs in here? No, you don't have any physical control, right? And actually there really isn't anything physical like even that I can do. I guess, so we say that, but technically you guys can come over here, I think go to properties of the virtual machine and then go over to the hardware tab and uncheck connected. And what that will do is unplug the network interface. So I guess you do have physical control, but we're not going to worry about that. So OSI model, physical layer, you got nothing for the most part. What kind of addresses and communications are we going to see at the second layer of the OSI model? Layer 1's wires. Layer 2 is it's a kind of address. What kind of address is at the second OSI model layer? What kind of addresses do switches use? MAC addresses. Is our router or our firewall here super concerned with MAC addresses? Not entirely. When we want to route and leave our subnet, how about when we communicate on the same subnet, do we use MAC addresses to communicate? Yeah, because we're just going through switches, layer 2, broadcast domain, all that good stuff. When we want to leave a subnet, the word subnet implies what kind of addresses are in use then? Layer 3. What kind of addresses are on layer 3? IP. Do we need to bridge the gap between layer 2 and layer 3? When you have a device on a network that needs to contact its router, does your device need to know the MAC address of the router? Or let's go another way. When you have two devices connected on a switch, do they need to know each other's MAC address in order to communicate? Yes. So when you have a computer and a router connected to a switch, do they need to know each other's MAC address in order to communicate? Yeah, they do. So in order for you to route then, if we mix that little layer 3 in there, do we need to tie someone's IP address to their MAC address? We need to be able to bridge that gap, right? So how can we check to see if that has been successful? Can you view the association of IP addresses to MAC addresses? Yeah, pretty easy. How do we do it? What's the protocol called? ARP. So if we come in here and do ARP and then -A in Windows, that will display the entire routing or ARP table. So your very first troubleshooting step, if you're absolutely stuck and cannot get communication to go from one device to a firewall or to a router, go into the device and say, well, are you at least ARPing it? So if we can ARP it, what does that tell us about the OSI model? What layer are we at least successfully connecting on? We got 1, we know that's for sure. If we've got MAC address information, we've got what layer? 2. And if we've got some IP address information, what's the other layer we've got? 3. So if you can come in here and do an ARP and you see your default route listed in here with a MAC address, you could go so far as to double check that that's correct. It's rare that it would not be correct. But if you come in there and ARP it and see an IP address and a MAC tied to each other for your default gateway, you now know that in some way this computer, which is server 1, has established some sort of communication to our firewall. Now, does that mean its traffic can go anywhere? No. All we have figured out now is that the server and the firewall can talk to each other. They're not sending grand messages. They're just kind of greeting each other like, hello, how are you? But that's as far as they go. They don't want to have any further conversation at this point. So that is our first step in making sure stuff can talk to each other. If you come in here and there is not an ARP entry for your default gateway, what are some things to check for? Yeah, you could just reboot it. Like, not gonna lie, rebooting things is not typically gonna hurt you at all. So, if you don't have an ARP entry in there, check the IP addresses that they're correct. Because if your firewall is not living at this IP address, but this particular device is looking for it, it's never gonna find it, and your firewall is never gonna reply. So if that layer 2 to 3 bridge isn't happening, you have something wrong with the way your interfaces are configured. So from in your firewall then, when we're troubleshooting and don't have ARP going on, go to your interface, make sure it's enabled for one thing, and scroll down and make sure that your IP address and subnet mask are correct. If your subnet mask isn't correct, you're also going to get ignored, because the firewall is going to be like, no, I'm not talking to you, subnets, bad stuff. So that is one place you can check. The other thing you can do, if you go to statuses and interfaces, you can double check. Now this is going to get crazy. You should be able to go to interfaces and see this MAC address. Where do you suppose the mystery? Where is this going to also appear at? What were we just looking at? ARP. So we should see 00505605 1F86. 051F86. Crazy they match, right? So that's an important thing. Real world exercise outside of the lab, make sure it's plugged in. That's going to be tough if it's not plugged in. There's one other trick we can do real world. It's not going to be so exciting to do here in the IA lab, but can we identify the hardware vendor? Yes. How do we do that? Yeah, that is called an OUI, or we go look up an OUI table. So if you search for OUI lookup tool, or you could just go like MAC address, figure out the vendor, Google that, and that'll probably get you in a pretty similar place. You don't have to use official. Let's try it. MAC address, figure out vendor. MacVendors.com. MAC vendor, boom. Find a MAC address vendor now. So yeah, you don't even have to use official terms. You can just like stab at it and it'll eventually come through for you. So another thing we could do is look up 005056. You don't even need the whole thing. Now, this is where it's not so exciting for us. Whoa, imagine that. Who manufactured that MAC address? You're not going to find a lot of variety in our virtual machines. It's pretty much always going to come back with that. However, at DSU, what are you going to find? I'll zoom out. Oh, didn't expect that. Well, that is curious. Oh, it's missing a digit? D44? You don't suppose it's something like that. Huh. Well, at DSU, when you do that, you should get Juniper Networks. So you're not on a Windows computer want to ARP it? Maybe I'm just being dumb with my Mac ARP table. What's that? Is it leading 0? I did a trailing 0. Oh yeah, there you go. Look at you, Tyler. So, we get Juniper Networks. So, as dumb as this may seem, in your life, if you're like, why is my computer not getting to the internet? Or why can I not get to the firewall? Or why can I not get to my router? Look up your ARP table, find your default gateway, do this. There was a time during a switchover 2 years ago at DSU where we were migrating equipment, where I expected Juniper Networks when I entered this. I entered it and I got back Cisco. And then I said, that's not right. So that told me there was a problem somewhere. And it probably had nothing to do with firewall rules at that point if I've got a layer 2 to 3 problem somewhere. So in our particular case, we're moving individual networks over to the new core network. And the network I was on was supposed to be moved, but somewhere along the line it was still connected to the old network and the new one at the same time. So we had 2 devices fighting to be the default gateway. Anywho, verify layer 2 connectivity. So if we've gone through layer 2 connectivity, what's another thing you could do to see if we can actually reach out and touch that address? Ping. Yeah, we can ping it. Now, off the cuff here, 64.43.152.1. Oh, I didn't expect it to succeed. Just play intermission music here for a second. Well, okay, so if you ping it and it succeeds, that tells you, hey, your interface must be working pretty good right now. I expected it to not succeed. So I'm going to go make it not succeed here for just a second. Oh. So let's delete that. There we go. Okay, so pretend that never worked. Okay, so yeah, this never worked. Does this mean, now at this point, again, we're crawling up the OSI model, and I actually, remember at the beginning of class when I'm like, hey, the OSI model actually matters. It's not just some stupid acronym for you to memorize and everyone ask you. There's reasons for it. So, crawling up the OSI model, this fails. Does this mean I can't talk to the firewall? No, I mean, obviously, I just did. I was successful for it. What is this possibly indicative of? Or what does this maybe indicate? So we could have the firewall wrong, or if we hadn't just gone through and done all the checking on ARP and all that stuff, it could mean our IP addresses are misconfigured. But we have a pretty good idea that that's correct now, because we just went through what do we got? 20, 25 minute tirade on ARP, which is probably the longest I've talked about it in my life. So we know that the IP addresses are correct. So now, yeah, we're left with a firewall. By default, and this is a tricky thing because we're supposed to use ping for troubleshooting, and for a lot of you that ask me questions would say, well, can you ping the firewall? And then I'd think oh, well, if they don't have a rule allowing it, that's not going to work. So then we would have that little exchange back and forth. So your firewall by default is going to allow what traffic through on the DMZ interface? Or really any interface? Or I could rephrase to say, how many rules are here in this list right now? Secretly there's one, right? Looks pretty empty, but what's the one rule that's in there? On the LAN, there is one there is one rule that's always there. On the other interfaces, though, what's the one secret hidden rule that exists on all firewalls? Delete, block, not just ping, but block everything. If you see a packet, delete it. That's what firewalls ship with. There's lots of engineers spent lots of time saying, if you see a packet, delete it. That's all firewalls do by default. They only let traffic through if you tell them to. So secretly, what's below on this list is delete everything you see, which is a pretty easy job for a firewall. They're pretty good at that. So the one exception is the LAN interface, which I'm going to quickly go review time now. So, Giovanna, why do we have this rule? Yeah. You notice we can't really easily delete this rule. This is allowing the LAN address, port 80. We'll come back to that one. So if I want to allow ping, if I want to do for troubleshooting purposes, let's try at DSU. For troubleshooting purposes, do we allow, look at that. Here at DSU, we allow people to ping your default gateway. Again, not a crazy concept, pretty common. Do you suppose we allow people from the internet to ping everything on our network? No. So, we probably have a rule that allows us just to ping the interface of the firewall, but not go anywhere. So, to do that, we go in and add. We're coming through here. If we want to allow someone to ping the DMZ interface, what's our action going to be? Crazy, right? We're going to allow it or pass it, yeah. What's the interface that we're going to do this on? Of our choices. So if we're going to allow someone to ping the DMZ interface, we're probably going to select probably the DMZ. So who is going to see the traffic first? It's going to be the DMZ. What address family are we going to do? Have we at any point done anything IP6? No. So just don't worry about IP6 in there. Just do IP4. How about protocol? This was a tricky one for a few people. Is there a TCP port for ping? No. What is our protocol we want to let in? ICMP. Which is a fancy word for what? Ping. Yeah. If we want to get really, really super technical, you can actually, there are different kinds of ICMP packets. Don't worry about it. We're not going to worry about that for now. There are, like when we come down in here, there is certain information like security-wise you could learn if a network like DSU allowed all ICMP traffic from the internet in. Like someone could basically trace route through our network and figure out what routers we have where. But we just block ping from coming in from the outside of our network. You can map out the inside. That's not so much a big deal. But, yeah. So we allow any. How about source? Do we need to put something here? Any will work just fine. What else could we put here? Aside if you wanted to get super specific. So we could do DMZ network. What's that going to say? So that's going to take the entire subnet of IP addresses on the DMZ interface. So we can take that subnet, that slant 24, and say, okay, allow that whole block of IP addresses to ping me. We could do that. We could specify a single host and just type in server 1's IP if we just wanted to allow server 1. We could actually manually type in the DMZ subnet, like IP address and subnet mask. Here's a tricky one. If we pick DMZ address, what will that allow? When we say DMZ address, or inside of pfSense when we see interface name and then address, what would that actually allow? Not actually the subnet. That's the tricky part. That's a common area where people get confused. So who owns the DMZ address? Where is that configured? Or if I would say, what is the address of the DMZ interface? What would you rattle off? No guess at all. So the address on the DMZ interface, like the actual default gateway, is what's represented by DMZ address. So if we picked this, what we are allowing now is the DMZ interface on the firewall to ping what? Itself. So you say router, but it is the router. So we would be allowing an interface on this firewall to ping itself, which seems kind of silly, right? There's not really a reason to do that. So we could do something like DMZNet or any. Those would be good options. When we go to destination, for this particular bit of troubleshooting, I want to allow someone on the DMZ network to be able to ping the DMZ interface of the firewall, and just that. So now what would I pick to do that? Yes, that's where we would do DMZ address. So now we're going to allow anyone on this network to ping the default gateway or the default route or the firewall's interface or whatever you want to call it. They're all the same thing. So now when we hit save, we see we are allowing, because it's a green checkbox, the IP4 pinging from any, when we see source, from any IP address on the DMZ network. And we know it's the DMZ network because we're under the DMZ tab. Ports are actually irrelevant because it's ICMP we're talking about. They can ping the DMZ interface, so the actual interface on the firewall. So now when I come back, I can verify that I can talk to the firewall. So, another question. OS differences. Why did Windows just give me 4? Versus what would anything other than Windows give me? Yeah, Windows is special, and Windows is a special little thing. So when you ping in Windows, it pings 4 times and stops. If you ping on Linux or Mac or BSD or anything other than Windows, how many times does it ping before it stops by default? Forever. Yeah, it just goes on and on and on forever. That's not a problem. You just stop it with Control-C, and it will stop pinging. Same actually within Windows. If it's pinging and you're done, press Control-C, and it'll stop pinging. I don't think you can actually make, maybe you can make Windows ping indefinitely. I think if you do like a count. Is it -T? Yeah. Oh, it's R. Does T go indefinitely?
I'm pretty sure. Yeah.
Oh, sure. I guess it would be silly to say ping indefinitely this many times. So, yeah, every other OS's ping utility goes indefinitely, whereas Windows just defaults to 4. Better or worse, I don't know. Don't really care. It's just what it does. Bill decided long ago that 4 is the number of times we shall ping. And 4 it shall be. So, at this point, can our DMZ machines ping the machine on the internet? Yay or nay? Can this machine that's on DMZ, when I keep saying this machine on DMZ, do you understand what that means?
Yes.
Okay. So I keep saying that and keep getting blank looks. Or maybe there's just something wrong this morning with everyone. I don't know. So we're talking about this machine on this network that has to go through this DMZ interface on the firewall. If we turn this here's another tricky one. If we turn this pfSense off, is anything going to work? No. For these firewall labs to work, you have to turn on the firewall. That's a very important part of the process. So double check that your machines are running. There's your physical layer question. If the firewall is off, you'll have physical layer problems. So DMZ to the internet. We want to allow one of the servers to ping the internet. So the servers all live inside of DMZ. We want to go out to the internet. Where would we put that rule? So that kind of becomes the tricky question.
Can DMZ talk to WAN?
Well, we haven't made a rule to allow DMZ to talk to WAN yet. So the question becomes, I'm going to highlight, we want to let this server, glowing in blue, to go out. So go out and talk to this machine over here. So where does the server have to go to get there? Has to go through the firewall to what interface first? Which we have labeled that interface what inside of pfSense? DMZ, yeah.
Sure.
When we get trickier firewalls, it'll be things like IF0 and IF1. You won't be able to make fun names for them. But in pfSense, we can name the interfaces. So when we make a firewall rule, and we need to decide what interface to apply it to, the rule of thumb that's accurate like pretty much every single 100% of the time, but I'm sure there's some reason why it wouldn't be 100% that I can't think of. When this machine wants to leave the network and we want to make a firewall rule to allow it, we make the rule on the interface that sees the packet first on our firewall. So when server 1 wants to leave its network, what interface of our firewall will see the packet first? The DMZ. What interface, so say server 1 is going to the internet, first DMZ will see it. Who's going to see the packet second? So if we're going out to the internet, it's going to be the, what was it called? WAN? Yeah. Does anyone care about second place? No. Some people do. But in the case of firewalls, we don't care about second place. So sometimes second place is okay. Taylor, you're in track. Second place isn't terrible, right?
Yeah, it's all right.
Yeah, see? So second place is okay, but in the case of firewalls, no one cares about second place, just first place. So if we want to let this machine travel down the little wire out this interface here, we need to configure the rule on the DMZ interface. So this is where we do it from. So we'll add a new rule, and let's say we're going to allow ping. Just for funsies again, we're going to allow the servers to ping the machine on the internet. Or we're going to say, I'll rephrase it, say we're going to allow the servers to ping anyone on the internet. Real world, would you probably do that? No. Do we want our servers to be able to get out to the internet like for any reason? Generally not, no. There's some specific instances where maybe, but generally we wouldn't make this on a real network. So come down, same thing. What's our protocol going to be? ICMP. What's our source? Let's get tricky, and let's now say we just want to let server 1. Server 2, we're not going to let him go. Just server 1. So what are we going to choose here? Single host or alias. I could talk about what aliases are too. Someone remind me of that. I'll get off on a tangent and forget about it. So single host. What address are we going to put in here? Yeah, whatever server 1's address is, which I do not know that off the top of my head. MSP server 1, 6443.152.100. And 64, 43, 152, 100. Make sure that's correct. Another pro tip. If you are frustrated using the IA lab, and I come over and find you're using your VMs like this, notice what's going on here? Scroll bar is not full screen. I have zero sympathy for you, and I wish you extra pain. I explicitly wish you extra pain. If you're using any virtual machine, not even the IA lab, like this, I'll go all the way to say I don't care if you have trouble. Full screen stuff so you can see what's going on, because the scroll bars are going to frustrate you. Don't get frustrated by scroll bars. Get frustrated by fat fingering an IP address. Have a real reason to get frustrated. Not a reason like you just did something silly. Now, at this point, we want to allow this computer, or the server one, to ping out to the internet. This comes down to the tough question of the day. What is the destination? So, we have to pick any if we're going to the internet. So when we talk about WAN address, who's the WAN address? That's us. That is the IP address configured on the WAN interface. If we pick WAN address, we will let server 1 ping an interface on our firewall and nothing else, because it's just that. The second one, if we pick WAN network, in the case of the lab, that would actually work, but that would not truly let you ping the WAN or the internet. What that will let you ping is the subnet between you and your internet provider. So when you look at WAN network, it's no different than DMZ network. When you do this, you are taking the network address configured on the DMZ interface. Same thing here. We would be taking the subnet configured on our WAN interface, and that's all. Is that subnet and subnet mask, which I think in this case is a slant 24, is that representative of the internet? No. Like I said, in the particular case of this particular lab, that probably would have actually worked for you to pick WAN network. I don't know if the lab even required you to ping server to internet or not. So that would have worked. But what you have to pick is any. Because do we have a thing in here to list all the IP addresses of the internet? No. That's why we have any. So then we would hit save.
Why does a PFSense have a destination? Destination like a lot of other
I don't know. That would be an excellent question to post in the forum. Why it doesn't have destination, or, well, most firewalls would use zones. So in the case of the IA lab, I would say, like, on a Juniper firewall, which we'll play with, we wouldn't necessarily configure the, well, no, you still configure an address. You just say an address of all.
limited to an interface.
Yeah.
Some way.
Yep. So, or a zone, typically like an untrusted zone, any address. Yeah. And that, I think, is what probably makes PFSense maybe easier to learn, but harder to use in a real business, because it doesn't do zoning like that. So, yeah. If we now, can server 1 ping anyone on the internet? We've achieved that. What else can server 1 now ping? It can ping anything on our LAN too, right? Is our firewall going to allow server 1 to cross over to this other interface? When we look at the destination, what's the destination? Anything. So when the DMZ interface receives that ping packet, it's going to look and say, well, server 1 can ping anywhere. So it will allow it to start scanning our internal network with pings of doom. So pings of doom aren't a thing anymore, unless you're an awful like SCADA controller or something. Otherwise, ping of death, like I'm going to send a big ping packet, really will probably just get the ping packet dropped now. So what could we do? Well, let's test to make sure. Can that machine now ping to the internet? I don't know. Let's look. I don't know. So yeah, as an FYI, I called this machine internet. My intent was like, this is a machine on the internet representing the whole internet when you're making firewall rules. That's why I have the little description of when I say ping the internet, I mean anything, not just this machine. So what that means is when I would say, allow the internet to browse your web server on the real world, are you going to configure one IP address as a destination or as a source? No. So can we ping that machine from server 1? Ping 24.220.181.100. And it's failing. Oh, then it started replying. I actually thought it was going to completely fail. So when it completely failed, what would be the next thing to check? So what is this machine potentially running? It's not. But what could it potentially run to block ping packets? Windows. What does Windows have in it? A firewall. Windows Firewall blocks pings by default. Well, it depends on what zone or what network it's configured to be on. So you might have to go deal with that. What if the WAN interface of our firewall was configured wrong? Would it work? Maybe if you get lucky, but probably not. So that's a couple things to check on. If we go on this internet machine, will it have ARPed the WAN interface of our firewall? Yeah, it will have. When we look at it, in this particular instance, the internet machine just happens to be directly connected to the WAN interface of our firewall. Is that the case of the real internet? You're not going to be able to go home and ARP DSU's firewall interface. There's only SDN and Mid-Continent can do that because they are our internet providers. So we can ping out to the internet, but let's go a step further and say, okay, you can ping the internet, but we don't want server 1 to be able to access like our LAN, our internal network. Do you usually want your DMZ network to access your internal network? No. So what do we need to do next in order to prevent that from happening? We have firewall rules that allow. What's another kind of firewall rule we can make? Deny. So if we add a rule, is our action going to be allow? No. We can do block or reject. I'll just do block. What interface is going to deal with this traffic? Or who is going to see it first? Let's come back here and look. Server 1 wants to access admin. What interface is going to see server 1's packet first? The DMZ. The LAN interface is going to come in what place? Second place, and we don't care about second place, right? So the interface is DMZ, address family. We could do ICMP, or we could just do any. Our source will be what? Server 1's IP address, right? Which I should just have the IP addresses for these written on a sticky note on my computer or something, so I don't have to keep flipping over here, but 60, 64, 43, 152.100. What is our destination now going to be? So we need to go down to LAN. So we've got it narrowed down to these two. Why LAN net and not LAN address? Yeah. So if we picked LAN address, what we would block is the DMZ, or the server 1, from pinging a firewall interface, the LAN firewall interface. And that's all we would block. When we pick LAN net, we mean the whole network or the subnet connected to LAN. So we'll block that. Save that. All right. Now at this point, have we done anything? Why?
It's after the allow all.
Yeah, it's after the allow all. Remember, we evaluate top down. So when we're evaluating top down, we're going to see this allow rule first, and we're going to pass the packet through. We're not going to stop it. So the new version of pfSense has a nifty drag and drop, just like that. And then we hit apply.
Would it not let you drag it again if you have to get apply changes or?
I don't, you'd still be able to. That was weird. Oh, apparently not. We need to apply changes first. Bloop. That is interesting. The apply button does not appear. Oh. Look at that. It's not going for us.
You just have to save it first. Hit save and then
Oh. There's a save button right there. Good find. Good find. Now the apply button comes up. So now, will this effectively block the traffic for us? Yeah. Other pro tips. A cool thing that the newer version of pfSense with the nifty drag and drop interface now does for us is it has a count. It's counting the number of packets that each rule has had applied to it. So if you're not getting your firewall rules to work and you're saying, well, I made a rule that does that, why isn't it going? If you hover over and it says, well, I've had 0 evaluations, meaning this rule has ran or been evaluated 0 times, 0 packets have applied to it, does that tell you that the rule has done anything? No, what that's telling you is we've checked the rule and it's never became true. So it's running a little counter for you. So ideally, when you're making firewall rules, your rules will do stuff. And if they don't do stuff, they're not doing anything, right? So check on that. So that counter was at 0. In theory now, if I come in here and ping 64, 43, 242, 100. So I'm now going to try to ping 64, 43, 242, 200, or 100. Really anything on the LAN network. It doesn't even have to be real. Ping it. Should it succeed? No. Ideally now, we should be able to come back here. We maybe have to refresh the page or give it a second. Hey, look what we got. It's counted 3 packets. I bet if I come back again, we'll get up to 4. Oh, how many ping packets does Windows send out? 4. That's where we got the 4 from. So, yeah. Check on those. See, the counters are actually doing stuff. Then you know that your rule must not be applying to something when you're playing around inside of here. That also goes for when you come over to system logs, which remember you're never supposed to go here because there's never useful information. If you're looking through here and there's nothing in here, that A means when I come back, like actually what I normally do is open a tab. So I can flip back and forth really quick. So are any of these 3 rules going to make any log entry? Aside from the happy little counter right here? Now, they're not going to make a log entry because I didn't tick the box saying, hey, log this when something happens. Then we hit apply. You notice you get the little like stat or a little bar graph there, I guess I would call it for lack of better terms. Now, although I'm not pinging right now, you can't log after the fact. When I go to ping it, it should appear inside of here. Eventually. The logs do take a second to refresh. The other one is if you have to check. Pretty sure if you reboot your firewall, these logs get erased every time. I'm pretty confident these logs are stored in a RAM drive. Which, how good is a RAM drive after a reboot? Not so good, because it's RAM, and when you reboot it, it goes away. So I come back, yeah, here's my ping packet getting blocked. There's also a lot of junk in here. We see, like, this generic traffic getting blocked. What was this traffic here? This is my admin machine source IP address going to the LAN's IP address on port 53. So what is my LAN computer or my admin machine trying to do? UDP 53. Who's that? That's right, I was going to give a port math quiz, wasn't I? What's UDP 53? Who is that? The little black book of the world. Lets you resolve names, and there we go. DNS. Windows is looking for friends. It's annoying that this is in here and is going to always be in there because this Windows machine is always going to be asking for DNS crap. So one way you can get rid of it is to just make a rule and say don't log it. So if we make, here we go, if I click, like pfSense will even make the rule for me. I'm adding an easy pass rule. We come over here. Look at that, easy pass rule, or easy rule passed from firewall log view. That is now going to allow the traffic, block the traffic, it's going to allow it. Either way, I don't care. What that is going to do is not log it, which means it's not going to clutter your logs. So if you see junk in there, just make a rule to get rid of the junk. And it won't be instantaneous. There's also UDP 137. That is Windows looking for love. It is sent out to what IP address? What would .255 be? It starts with a B. Yeah, it's a broadcast address. That is Windows sending out a beacon being like, hey everybody, here I am, let's be friends. Which is super annoying that Windows does that, but it just does. So that is going to clutter your log because it's Windows. So you could also make a rule to allow or block it, I don't care. But just don't log it, and that's okay. So, for something new, I was going to talk about aliases. So we'll at least covered one new thing today. So, as you can tell, even when I'm up here, and I'm the one that set all of these IP addresses, I don't have the slightest idea what they are, right? I have to keep looking every time. 64, 43, 152.100. What if instead I could use a variable? And for those of you that hate programming, I'm not trying to like bring back dark days of like being in 150 or something. But variables are pretty nifty because you can reuse them. It's really cool. So pfSense calls them aliases. Most other firewalls just call it an address book. That's really what we're doing, is making an address book. So if we go to aliases, there are many different types of aliases we can make. For now, we're just going to worry about IP aliases. If we add a new alias, I could call it something like MSP server 1. Give it a description like server 1 on the DMZ or something clever like that. Then down here, I can type in its IP address, 6443, again, don't remember it, 6443, 152.100, come back in here, 152.100, whoops, click in here, 152.100, and let's see, hit save. So here's something cool now. I'm going to apply that. Go into rules, and I'm going to go edit the DMZ rule to block that. Okay? We'll come back down here where we had single host or alias. If you watch something really cool, if I just start to type letters instead of an IP address, my aliases will come up. So now I can allow it from MSP server 1 or whatever you called it. Hit save. It'll even show up here as MSP server 1. And then when you hover over it, it'll tell you the value. Generally speaking, most like commercial firewalls will not actually let you make rules with just IP addresses. You'll never make a rule allowing 192.168.1.100 to go to Facebook. You would make a rule saying allow Kyle's computer to go to Facebook. And then you'd make an alias somewhere in between. Lots of reasons for that. Old school firewalls, that was not the case. You had to do everything by IP addresses. But places start to get lots and lots of IP addresses. And the more IP addresses you get, what are you more likely to do? Many things, but forget, fat finger, lots of them start with F. I'll let you figure out the rest. But either way, lots and lots of different things can go wrong. So we started making aliases to help you keep track of them. There's one other fun troubleshooting tool. When things have really hit the fan and you're really having troubles with something, you can go and do a packet capture. So packet captures are super, super handy because you can see what's really going on. So if you want to see what's going on the WAN interface, let's take back to our example in the network diagram, allowing server 1 to go to the internet. If we're having troubles with that, what interface did we make the rule on again? I'm going to beat this to death. What's the first place rule or first place interface? The DMZ. Who's second place if we're going from server 1 to the internet? WAN. The WAN interface right here. So we know the WAN interface is going to see the packet, right? So if we're trying to figure out why our traffic is or is not flowing, we could capture it on the WAN interface. Like, we want to scrape in all traffic from the WAN. When we ping from a DMZ server to the internet, will WAN see it? It's second place, so it doesn't get as much love, but the packet has to leave that interface, right? So we can come down here, and there's all sorts of specific things, like you can specify IP4, IP6. Let's go through in here and say, I only want to capture pings. You can even specify an exact IP address, an exact port. Let's go start. Scroll down here. It's going to capture either the first 100 packets or until I click stop. So it's going to take it a while to get to 100 packets because there's no traffic here. So if I come back and try to ping the internet, in this case it actually succeeds, but while I'm pinging the internet, if I come over here and hit stop, scroll down, it has a log of the traffic. So we can see server 1 going out to that internet machine, echo request. Then what do we see next? Echo reply. That's how ping works. Ping pong, back and forth like that. So if we just saw echo requests going out and no echo reply, we have a pretty good idea that our firewall is probably working. If we see the traffic we intended to let out going out, but it's never coming back, then maybe there's something wrong with the machine on the other side. So then there'd maybe be something wrong with the internet machine or something like that. We could actually simulate that exact problem by saying there's something wrong with the internet machine. In my case, I'm just going to turn it off. Come back here, start the packet capture again. There we go. Start it. Come over here and try to ping again. Pretty obvious issue, right? It's off. Is it going to reply to a ping? Probably not. But we can still check if our firewall rules are okay. So let's stop. Come down here and look. And now we just see server 1 going out to the internet saying echo request. Do we see a packet coming back from it? No, because it's not on, so it's not going to reply. But this is telling us at least that the packet is in fact leaving our network and getting out somewhere. So, are there any other firewall troubleshooting questions? Nothing? Okay. I'm going to hang it up for the day then.